Cepheid is a molecular diagnostics company that develops, manufactures, and markets integrated systems for testing in the clinical market. Their main product is the Gene Expert cartridge. As shown in the video, the plastic cartridge is made of several components, such as the base, the body, multiple valves, and the lid. With this product, medical professionals administer tests that check for approximately 30 different conditions. This product must be airtight to successfully run the clinical test. However, only certain combinations of components and assembly lines produce airtight cartridges. This leads to various restrictions in production. Each clinical test has about 15 different restriction types that planners must validate. These restrictions are documented in non-normalized Excel files, which results in inefficient organization and visualization of data. This all leads to our main problem, which is that the inefficient management of restrictions data increases labor hours and human error because planners must tediously schedule production around these restrictions. This leads to increased scrap and labor costs, lowering overall profit.
In order to gain knowledge on this problem, we focus on 3 areas of research. First, we conducted research on database unification and visualization. Unifying denormalized data sources into a cohesive database is difficult because relations lack primary keys and include sets of data. One option is to leave tables denormalized and use recursive queries. Using SQL, constructors can nest queries and allow lists and single cells to exist. This will minimize the number of tables and promote a more readable state of the data. Another option is to transform the data sources into a relational database system. By doing so, faster querying can take place. To make basic action queries more straightforward, third normal form and first normal form tables are a must.
When researching different manufacturing optimization models, we found an example at Baxter that used a cluster analysis method to create a sequence-dependent schedule. Additionally, at Dell, they utilized linear optimization programs to create lane assignments, sequences, and schedules for production. If we implement a validation tool, it will need to confirm that allocations from the production plan do not validate any restrictions. To prepare for creating this, we researched query logic, ActiveS data objects, and record set loops.
Moving into the design strategy, we first identified the current state as consisting of multiple denormalized Excel files. These files must be manually updated, and it is not possible to quickly retrieve the necessary restrictions data. For example, when looking at mold and line restrictions for the Carba R product, it is difficult to extract the exact combinations that are qualified to run. Similarly, certain single cells contain multiple statements regarding what lid, body, and line are acceptable.
The design strategy required looking at 2 different aspects of the design, the database and the planning tool. The database should improve organization and visualization of all of the restrictions data and be built in Microsoft Access. The planning tool is meant to improve the planning process by using the restrictions database to reduce the workload of planners.
The structure of our database will be built in third normal form, meaning that the qualification status will be fully functionally dependent on the unique combination of production variables. Partial dependencies on the composite key will be placed in a separate list table to maintain normal form. Because of this complex design, select queries will allow users to view and edit restrictions records related to a specific part number. With this unified network, data integrity will remain consistent across all platforms. As for the interface, buttons will easily navigate these different component restrictions forms.
When designing the interface of the database, we had 2 main alternatives, each producing a slightly different background structure of the database. Our first option was to utilize action queries such as append, update, and delete to edit the data tables. In this alternative, users would side-select a record and use text boxes and buttons to edit the information. This minimizes the mistakes that could be made by users editing data. The second alternative is allowing planners to edit data within the subform, eliminating the need for any text boxes or buttons. This provides a much cleaner layout, but requires planners to be precise with their data manipulation. For the planning tool, our first alternative was an optimization model that used the restrictions database, SAP demand data, and an advanced version of Excel solver to create a production plan. The second alternative is an allocation validator that reads in the production plan from SAP and ensures that each allocation does not violate any of the restrictions found in the database. This alternative requires much more VBA coding, while the optimization model can be completed primarily in OpenSolver.
In order to ensure our database design meets Cepheid's requirements, we thoroughly tested each function. First, we made sure that the selection of a part number from the combo box would retrieve all records related to that part number. Because the production planners prefer to edit within the subform, we made sure that new entries added within the subform would also be added to the table. And in order to guarantee data integrity, certain fields were locked. Finally, we confirmed that a side selection populates text boxes and that an append query adds the same record to the corresponding production status table. This maintains consistency between the qualification status and production status tables. Overall, this procedure confirmed the performance of our database. After testing each interface and considering our sponsor's preferences, we recommend Alternative 2 for the database interface design. Editing within the subform allows for greater visibility of the data, and the cleaner layout is more user-compatible. In addition, the side selection of an added record and the following append button will ensure parallel production and qualification status tables. After discussing both alternatives for the planning tool, our sponsor at Cepheid decided the allocation validator would be more beneficial to the planning process. This is primarily due to the fact that SAP already creates a production plan based on forecasted demand. Our tool improves the planning process by ensuring that this production plan does not violate the restrictions, saving the planning team the hassle of checking these restrictions manually.
Throughout this project, we utilized many database management skills from IME 312 to design our database, computer programming skills to create the validation tool, and operations research skills to develop the optimization model alternative.
The secondary impacts we must consider throughout the project include environmental, safety and health, and cybersecurity impacts. The allocation of resources should not only optimize production throughput, but it should also minimize waste, including unnecessary machine energy and scrap material. Additionally, supplier selection should be ethical as well, prioritizing how materials are produced over buying materials at the lowest cost. The goal of our database is to efficiently plan the production of an airtight product. If not error-proof, an employee could qualify a non-airtight combination. A licensed administrator also needs to qualify the production status of a production plan to ensure FDA standards are upheld. If this product is not airtight, then the clinical test could be unsuccessful in catching the disease, resulting in a safety hazard for the patient. Lastly, with information transactions being completed between an Access file owned by multiple employees and an SAP data source, data integrity could be at risk. Although our current database has preventative measures, this will be a concern as we pass along our project to Cepheid.
Moving forward, our database will be used as a model for the database utilized in Cepheid's future manufacturing execution system. Additionally, the database will be linked to an SQL backend server to protect the data. We also recommend that the validation tool be further enhanced to check for restrictions on CAL lines and PAL lines.